Ideal and non-ideal solution based on Rolle's law. Ideal solution. Ideal solution are those which follow Rolle's law. So we should know about the Rolle's law. We have already discussed in our previous class about the Rolle's law. According to this law, partial pressure of a gas at surface of the liquid is directly proportional to the mole fraction of that gas. Okay, students, let us consider we have solute A. We have solute A and solvent B. Solvent B. If we mix solute and solvent, and if we add XA mole fraction of A and XB mole fraction of the B, then here we have solution of A and B. So students, according to the Rolle's law, here partial pressure of A in this solution is directly proportional to the mole fraction, and mole fraction of A is XA. So PA is directly proportional to the XA. Now put the constant of proportionality. Here constant of proportionality we can take pressure of that component in pure state B. Then students, PA is equal to P naught A XA and PB is equal to P naught B equal to P naught B XB. And total pressure is the partial pressure of A and partial pressure of B. So PT is equal to PA plus PB. Okay, students. So this is the Rolle's law. And ideal solutions are those which follow all these conditions. Means in which PA is equal to P naught A XA, PB is equal to P naught B XB, and P total is equal to PA plus PB. If all conditions are followed by the solution, then it is known as the ideal solution. Okay, students. Now, the enthalpy of mixing. The enthalpy of mixing of two components should be 0, or change in enthalpy delta H mixing should be 0. What do you mean by this? Students, let us consider we have solute A. So particles of solute have some interaction between them, and we have solvent B. So particles of B also have some interaction. So interaction means force between the components. If we mix both of these, then they will form some new bonds and they form A, B. Okay, students. So if here we need some energy to break this bond, and we need some energy to break this bond. Students, let us consider we need 10 joule energy for breaking this one, and 10 joule energy is required for breaking this bond, the bond between B and B components. And after mixing with them, AB is forming. Let us consider by forming the bond between A and B, the amount of heat is released, it is evolved, and let us consider it is 20 joule. So students, here we can see, here 10 plus 10, total 20 joule energy is absorbed. And this amount of energy, 20 joule, this amount of energy is released. when formation of bond take place between A and B. Here amount of absorption of energy as well as amount of evolution of energy both is same. So here change in energy 20 minus 20. Here delta H is 20 minus 20. It is equal to 0. Okay. So in case of ideal solution, enthalpy of mixing of two components is 0. Means which amount of energy is absorbed, same amount of energy will be released. Now move to the point 3. Volume of the mixing is equal to 0. Again students, let us consider we are taking solute A. We are taking it 10 ml. And if we have solvent B, it is also 10 ml. So students, what will we accept? Here our acceptation is we will get 20 ml of the solution, and in case of the after mixing we get A plus B. Here we should get 20 ml of the solution and we get this one. So here we take total volume is 20 ml. And after mixing, we are getting also 20 ml. So again here change in volume is 0. So in case of the ideal solution, solute interaction, the solute-solute interaction and solvent-solvent interaction is almost similar to the solute-solvent interaction. What do you mean by this, students? Students, let us consider the interaction between AA and interaction between components of the B. After mixing, they are giving us AB. So, which force of attraction exists between AA particles and between BB particle? After mixing, we are getting AB. If interaction is same between A and B also, then they are known as the ideal solution. Means अगर हमारे जो A और A के बीच जो इंटरेक्शन है and B जब ये प्योर स्टेट में है, जो इनके बीच में इंटरेक्शन है, सेम इंटरेक्शन हमारी मिक्सिंग के बाद भी वही इंटरेक्शन अगर हमें मिले, देन सॉल्यूशन इज नोन एज द आइडियल सॉल्यूशन. For example, students, here we have N-hexane and N-heptane. N-hexane, hexane means 6 carbon, CH3, CH2, 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 CH3. And other molecule of the N-hexane we can take so here students, bond between carbon and hydrogen will take place, and if we interact N-heptane and N-hexane, then there will be the same interaction, there will be the same force of attraction again. Means their interaction is same after mixing and before mixing. Now we move to the non-ideal solutions. Non-ideal solution, the solute and solvent interaction is different from that of the solute-solvent interaction. Means इनके बीच की जो interaction है after mixing, their interaction, the interaction between AA and interaction between BB. When we mix A and B, then we get AB. If interaction between A and B, either it will be the less than interaction of AA and BB, or it will be greater as compared to the interaction between AA and BB, then the solution is known as the non-ideal solution. And on basis of this interaction, we divide the non-ideal solution in two types. First one is non-ideal solution showing positive deviation and non-ideal solution showing the negative deviation. So students, if this interaction is greater between the interaction between AA and BB, then solution will show the, if this interaction is greater, then solution will show the positive deviation. What type of the deviation it will show? It will show positive deviation. And if if this interaction is greater, then it will show the negative deviation. And if this interaction is less between the interaction of AA and BB, then they will show the positive deviation. So यहाँ पर क्या होगा, या तो ये इंटरेक्शन सोल्यूट पार्टिकल्स एंड सोलवेंट पार्टिकल से कम होगी या फिर उससे क्या होगी, ज्यादा होगी. अगर इंटरेक्शन हमारी पहले से कम है तो सॉल्यूशन किस टाइप का डेविएशन दिखाएगा? इट विल शो द पॉजिटिव डेविएशन. और अगर हमारे इंटरेक्शन पहले से ज्यादा है देन इट विल शो द नेगेटिव डेविएशन. सो here delta H mixing will not be equal to the 0. Delta H mixing in case of ideal solution it will be 0, but in case of the non-ideal solution delta H mixing will not equal to be 0. Either it will be greater than 0 or it will be less than 0. If it is greater than 0, then it will show positive deviation. And if it is less than 0, then it will show the negative deviation. Again, delta V means change in volume is also not equal to the 0. Either it will be greater than 0 or it will be less than 0. If it is greater than 0, then it will show positive deviation. Or if it is less than 0, then it will show the negative deviation. And students, non-ideal solution do not follow the ideal solution. Do not follow the ideal means they do not follow the Rolle's law. They do not follow Rolle's law. Means either PA is greater than equal to greater than P naught A XA or it is less than P naught A XA. If it is greater, then it show the positive deviation. If it is less, then it show the negative deviation. Or P total is either greater than sum of partial pressure of all component or it is less. If it is greater, then it show the positive deviation, and if it is less, then it show the negative deviation. Examples: ethanol and water. Students, you can see ethanol and water. They show the positive deviation. Why? Because here these two molecules show the hydrogen bonding between them, and water molecules also. They form hydrogen bonding between them. And after mixing, if they form bond between ethanol and water, then extent of this hydrogen bonding will be less as compared to the hydrogen bonding when they combine with the molecules of yourself itself. Okay students, so here जो पहले इनके बीच में इथेनॉल और इथेनॉल के मॉलिक्यूल्स के बीच में जो हाइड्रोजन बॉन्डिंग है और वाटर मॉलिक्यूल्स के बीच जो हाइड्रोजन बॉन्डिंग है, तो इनकी कॉम्बिनेशन, इनकी मिक्सिंग के बाद जो हमारी इथेनॉल और वाटर मॉलिक्यूल्स के बीच जो हाइड्रोजन बॉन्डिंग बनेगी, ये हमारी क्या बनेगी? एट स्मॉल एक्सटेंट, एट स्मॉल एक्सटेंट इट इज वीकर फोर्स ऑफ अट्रैक्शन. So they show the positive deviation. And students, here chloroform and benzene, or we can take example of chloroform and acetone also. CHCl3, this is the formula of chloroform, and CH3, COCH3, this is the formula of acetone. Okay, so here if other molecule of the acetone is interacted with one molecule of acetone, then they do not form hydrogen bonding. They do not form hydrogen bonding. But students, when molecule of chloroform and one molecule of acetone, they react with each other, then they form, this is chloroform. If it reacts with acetone molecule, then it will form hydrogen bond. It make the hydrogen bonding. Means here force of attraction is greater as compared to the force of attraction between molecules of chloroform and the force of attraction between the benzene molecules itself. So here force of attraction is greater. So they show the negative deviation. So students, today we discussed about the ideal and non-ideal student solution, and in next video we will discuss about the positive and negative deviation with their graphical representation. Thank you. Have a nice day. आज की वीडियो बढ़िया ना बनी, आज नहीं, एक दो बार ये होने से